Hello, everyone, and welcome to another episode of Open Observability Talks. I'm your host, Liran Haimovitch, and here at Open Observability Talks, we talk about anything DevOps, observability, and open source, of course. I'd like to thank our sponsors, Logs.io, the cloud-native observability platform. Logs.io takes the best of breed open source projects such as Prometheus, Elasticsearch, OpenSearch, and Jaeger, and offers them as a unified observability platform built for scale. For those joining the live stream on YouTube or Twitch, feel free to share questions and comments on the chat. It makes things much more fun for us. We're here on the Fireside Chat. And with that, let's move on to today's episode. Today, we'll discuss what observability means for developers, how to determine what developers should be monitoring, how observability fits into our current dev tools and processes, and how it can actually be fun. My guest today is Liran Haimovitch, co-founder and CTO of Rookout, and an observability and instrumentation expert, and a fellow podcaster as well. So I'd like to invite Liran to join me. Hey, Liran, good morning.
Hey, Lotan, how are you?
Great to have you here on the podcast and on the same time zone, so it makes it easier this time around. So Liran, can you tell us your personal journey into the observability space?
Sure. So, like many Israeli entrepreneurs, before early on in my career, I spent a lot of time in cybersecurity. I actually spent almost a decade doing cybersecurity, endpoint security, network security, kind of reverse engineering stuff, rebuilding stuff, and making it, understanding how things can be modified, especially at runtime. And then now about 6 years ago, I kind of decided it's time to move away from cybersecurity and kind of try something new, which ended up being DevTools, which is, I think, a passion and dream for every developer out there that knows that they're just going to fix everything that's wrong with how software is being developed. Everything from
we feel the pain,
Yeah, we feel the pain. We think it has to be better somehow. And kind of going into that, I kind of try to take my personal experience from cybersecurity, from reverse engineering, from instrumentation, and try to bring a unique and new perspective on how developer tools in general, especially how observability is done.
Sounds good. So when you talk about observability, everyone says you need to monitor well, but the basic question is, how do you know what to monitor and which data to collect? Curious about your insight there.
So I would argue that you just don't. You never do. I mean, you can get a great start by looking at the past, whether it's your experience in other companies, in other products, in other roles, or whether it's just the incidents you had over the past week, day, month, year, whatever. And those are great learning opportunities. And the more you learn from them, the more you bring experience to the field, then the better it is. But at the end of the day, you really don't know because everything is constantly changing. Your system is changing, your environment is changing, your cloud provider is changing, and you just can't know for sure that you have great monitoring and that whatever is going to go wrong, you're going to have it. Also, it can be very hard to, you never know when observability costs, whether it's in performance costs or monetary costs, are just going to shoot through the roof because something that felt super important just hours ago is now happening thousands of times a second, and you're all of a sudden paying lots of money for it. So to me, great observability is about continuous feedback and continuous learning and continuous improvement more than it is about any specific state you hope to achieve.
Yeah, I think it's a very good point that you're saying about the fact that it's not a one-off, and with all due respect to experience from other companies or from references, it is an iterative process, and you need to improve the RCA. But do you identify, sort of from your aggregated experience, both yourself and also working with customers, sort of guidelines or best practices that you found about, let's say, the baseline at least of what to collect and what to monitor, or the common defaults. Maybe some tools come with defaults, but I'm not sure that they're really what I would use. So I'm curious about your take on that.
So first, when you look at things, you kind of have two key starting points I would look at. First is whatever is coming out of the box. And many tools you're going to use are going to have some observability out of the box, whether it's a web framework you're using, whether it's an APM or a open telemetry itself. The project you're a big part of has a lot of built-in capabilities. And start with whatever you have out of the box. It's not going to be perfect. It's definitely not tailored for you, but it's something that was built out of a combined experience of many people out there. And just as important, it's cheap. It's as cheap as it gets because somebody has already provided it for you. So it's a great starting point. The ROI for that is going to be great. And especially as we discussed that observability is all about learning, if you start with a turnkey solution, then you're going to start learning immediately. Obviously, when it's a turnkey solution, you have to think about how you improve it over time and how do you input your learning into whatever system you're looking at. Now, the other side of monitoring is trying to take it as close as possible to the user and to the business. Try to get at least a handful of metrics that indicate the health of the system from the user perspective, from the business perspective, whether it's how much money we're making, whether it's how many users we're seeing. Facebook is very famous at using the like button as their key health metrics, because if people are liking on Facebook, then all the servers might be down, but we are fine. On the other hand, if people aren't liking on Facebook, it doesn't really matter if it's because of a latency issue or a network issue or error rate or a database or just a UX issue, because something is broken, the business is not thriving, let's fix that. And obviously, there are challenges to that. You have to pick an event that's occurring often enough, because you can't rely on something that happens once a week for monitoring. You probably want something that happens somewhere between a few times a minute to a few times a second at the very least. And once you have that frequency, then you have to look at variance and rates and so on. Now, a simple proxy for that, which is not as good but often a turnkey, is looking at endpoints, at API endpoints, looking at their latency, looking at their error rates, looking at their RPS. As long as those are staying within a pre-specified boundaries, it's not business level metrics, but it's service level metrics. And often it's a great start. And also, you'll often find it as one of those turnkey options you can have in the tools I've mentioned earlier.
Yeah, I think it resonates well with a discussion that I had here a few months ago about SLOs, service level objectives, and how defining very well the SLOs to map, obviously, to, as you said, the ones that make the impact. I think I really like the like example that you gave, like button at Facebook. The things that really move the needle, because some things can break and they don't have any significant impact on the end customer, then it's definitely a different urgency level than something that bears significant, that the customer immediately sees, the user immediately feels, and ruins basic flows that are critical in the system for the end user perspective.
Now, the tricky part is that kind of everything I've mentioned falls into the category of what you would call traditional monitoring, where you're just trying to see things from an operational perspective, from an SRE perspective, kind of, is the system up or down? Is it operating well? Do I have to, turn on the fire alarm and say something is broken, we have to fix that? Which is what I think most organizations look at first and foremost when they think of observability. But at the same time, it's also important, At the same time, it's also important to look at other stakeholders. Observability is not just about SREs that are looking to see if the system is up or down. Observability is also about engineers who are trying to fix bugs. It's about engineers who need to understand the system to scale it, to migrate to migrate to a new database, to migrate to a new framework, to add a new feature, to deprecate a feature. And obviously other consumers may be product, maybe BI. And in many cases, those, those people are going to be asking completely different questions than the questions we've just described, and they're going to be looking at very different data. And quite often, they won't be asking the same question day in, day out. They don't care just, is the system up, is the system down? They're going to be asking different questions every day based on whatever task they're working on that day.
So I think you're leading to, I guess, the topic of our chat today, which is to focus about observability for developers. And you started touching about that the fact that we all know observability in the context, or at least many of us know the observability in the context of ops or DevOps. But the focus today is, and today's chat is about developers. And the question is what observability means for developers. So how is observability for dev different than observability for ops from your perspective?
So, well, I kind of touched on that, and observability for dev is more about facilitating the day-to-day tasks of developers. So it's not just about identifying is the system up or down, not even about identifying where the bottlenecks or the risks might be, but it goes a few steps deeper. It's whether it's about answering architectural decisions, such as, do I need to change the database am I using, and to what database? Do I need to change my queue? Do I need to move from an RPC-based approach, a network RPC-based approach, to a queue-based approach? Those are architectural questions that we ask. But more often than not, they're very daily questions, such as, I just got a ticket about a bug, how do I fix it? Even more so today, as more and more engineering is actually carried out on cloud environments and not local environments, then even the development environments can become very opaque and very far and remote. And all of a sudden, you find engineers using observability tools in their pre-production environments regularly. And obviously, they have tons of bugs in the pre-production environments. They have tons of bugs in development environments because that's what those environments are for. They're for testing untested code. They're for testing code that is not ready. So there are going to be tons of bugs there. And then engineers need to dive in deeper, dive into the source code, dive into the variable values, try to get a sense of how the code is flowing and why. And obviously, it goes the same for other tasks. Let's say I'm rewriting an API from Ruby to Golang. Then all of a sudden, of course, I can look at the API, I can look at the source code, but I'm going to learn so much more if I'm going to see how this API is actually being invoked in real time today, what real inputs and outputs are getting into it, and not just about what's the error rate or what's the RPS. Maybe I'm looking at deprecating a feature or partially deprecating a feature. I want to see if it is being used and by who. Maybe I'm looking to adapt a feature, and I'm kind of wondering, do I have to take a look at all the flows or just some of them? And the list goes on and on and on. And many of us have been developers. You get a different Jira ticket every day, and then you're off to the races trying to figure out whatever that product manager in his mind wrote, and they think that's going to be awesome. Now you have to dive deep into the code, dive into the tech, and see how close is the reality to what's in the ticket, and what do I need to know to make it happen.
Yeah, I think it's very different, and obviously the development tasks are very varied in terms of the observability needs. I would argue another thing that is for me a very significant difference between the let's say the ops type of or DevOps type of observability and which is the skill set, because it's not just tools, it's also processes and the people out there that are involved. And developers are typically maybe less specialized in observability. So for them, maybe it might be a bit harder to use metrics, maybe more so to do tracing, all these P99s and P95s and all sorts of histograms and things like that maybe are less accustomed to than the typical SRE or DevOps. And then there's another level of challenge that comes to mind, which is how to make it accessible so for developers. Have you encountered this sort of skill set or familiarity challenge?
Definitely. I think we're seeing that metrics and traces are used to great impact by specialized teams. I mean, Google built a planet spanning services using metrics alone, using their Prometheus predecessors, Bogmon, and having Bogmons on top of Bogmons on top of Bogmons. And obviously, you can do that if you are part of the observability team in Google, and that's your job, that's what you're specializing on. Uh, and we're seeing more and more people specialize in observability, in metrics, in traces. But still, I mean, you know the servers. I know you guys at Logs.io conduct them very regularly. Logs are still by far and large the most popular observability tool. I mean, it's coming up in most surveys to be about 4 or 6 times more popular than next runner-up. And the reason is that logs are so simple. They're truly as simple as it gets. Once you write your first hello world application, you know what are logs, how to use them, how to analyze them. No black magic involved, no complex statistical analysis or data aggregation or anything like that. What you see is what you get. Very, very simple. And so I think that's one of the key tools for the hobbyist. So of course the professional observability, which are usually just a handful, maybe a centralized team, maybe a domain owner in every group. Those people, they know their stuff, they know metrics, they know tracing. The rest of the team who don't have the time and the interest to specialize in that often stick with simpler stuff, such as logs, such as application snapshots, where they can just see the state of the application. Maybe they are looking at profiling data. But they don't have the time and knowledge to dive into those super hyper specialized tools that sometimes the observability industry is so excited about because they're awesome, they look good, and if you're really into it, then that's amazing.
No, I think you brought something that is interesting about in organizations, that sometimes you actually need support to actually make it successful with the developers. You need, in many cases, especially when the organization is big enough or scaled out enough, that you need some sort of a specialized team, not to replace. So the engineers still need to own the observability, need to have it as part of the culture, but at least they have a specialized team that can take off the load of setting up the tech stack behind the observability, and help guide them through, as you said, the more sophisticated types of telemetry that are also maybe less familiar. Tracing is very fairly young, especially in comparison to logs that has been around for decades. So educating people on how it works and to the level that they need to feel comfortable using it. So and this is I know that you also know Suman Karumuri. We even had it hosted him in your podcast. So one of the things that came in our discussion here in Open Observability Talks was around who owns observability and how this becomes very crucial as the organization grows and the engineering organization grows. So I think this is an interesting point. Sorry, but so to take it to the practicalities, because each engineering organization already has its set of dev tools and dev stack and dev processes. So how does observability fit into that existing set of tools and stack and so on?
So I think it's first and foremost a question of, as you mentioned, ownership. Now, obviously, you would in most organizations you see centralized teams, you see SREs or operations owning observability, and you see that they usually have three main responsibilities. The first of that is kind of maintaining any observability tools you have, whether it's commercial, in which case it's mostly about picking the vendors and making sure they're paid on time, or it's about open source where you have to maintain and deploy it. In some cases, larger companies such as Uber and Slack even develop their own tools internally and often distribute it to open source later on. Second is kind of managing those company-wide observability challenges, especially if you don't know where is the problem coming from, and you need a lot of advanced analysis to kind of try to pinpoint it, maybe have a multi-team effort. So those are those kind of things. And last and definitely not least, as you mentioned, it's kind of about spreading the word. The thing is, where many of those teams fail is that they assume that whatever tools work best for them are going to work best for the average engineer. And the average engineers are definitely getting assistance out of those centralized teams. Let's say if an engineer has a problem that requires a performance problem and he's looking at tracing data and he gets stuck, he's probably going to reach out to the centralized team to get help. And essentially, they're quite often just going to sit together, whether it's on Zoom or shoulder to shoulder in the same office, look at the data and try to figure it out. But the thing is, quite often that engineer is not going to be any better off next time, because tracing can be so complex and metrics can be so complex that the next time he runs into a significant problem, he's going to need that team's assistant again. And he's not very likely to be able to help his team members, especially if different people run into that similar issues. And that's, I think, where it gets stuck. We've built amazing technologies for observability, but they're tailored for the power users, not for the everyday users. And for those users, I think we kind of need to change our approach and say, even those users are not our power observability users, and even though they don't necessarily need to use observability every single day, we actually want them to use observability every single day because we want them to be more connected to the production environments, to the code they're owning in production. We definitely see a lot of potential in them using observability tools in pre-production environments to speed up their work and deliver higher quality software. And so we need to think of them as very important consumers of the observability stack, and we need to make sure we tailor tools for them as well, and not just for our power users who get all the glory and all the budget for choosing their observability tool of choice.
So the question, just to take it to the practical level, because the developer is familiar with his IDE. Most of the time is spent on the IDE. Even being able to run from the IDE things like shell commands and things like that. Like, developers like living as much as possible in their IDE, and then they have some local dev environments like local Kubernetes deployments and things like that, and other parts of their dev stack. And the question is, can we somehow bring, at least that's what I envision, but curious on bring it closer to what the daily work of the developer is, so it becomes integrative enough to the point that it's a no-brainer, it's an effortless as much as possible, so that to remove the barriers, or at least reduce the barriers to entry.
I would argue that kind of like we've optimized the pillar of observability for SREs, and we've first added metrics for monitoring at scale where logs fail us, and added tracing for monitoring in depth where complexity rises. We need to think about what pillars do engineers need, and what pillars would provide them with the best experience for their needs that would be the most familiar for them. One of the things we found at Rookout is that developers love application snapshots. They love to be able to tell the state of the application at a given line of code, whether it's around seeing the full stack trace to see how we got here, whether it's about seeing which endpoint was invoked, and especially about seeing what are all of the values of all the variables in context. And it's so much easier to read that than a log line. It's so much deeper, so much more comprehensive, and it's great for the day-to-day tasks engineers have to deal with, and the questions they ask, the observability questions they ask as a result of that. Now, those snapshots tend to be of fairly little value for operations because they're looking at the big pictures. They care about, is it up or is it down? They don't care about the nitty-gritty details, which most engineers do care about. Engineers should care about the whole end state health of the system, but they care first and foremost about their source code, and is it right or is it wrong? Is it serving the customers? and we want them to connect to that source code in production. Because the harder it is for them to see their source code in production, the more they're going to be focused on their source code in staging, or even worse, on their local machine. And we don't want that. We want engineers focused on their code in production, so we need to give them tools such as Snapshot that make it happen, that make it possible.
So maybe you brought up something that is interesting, snapshots, and I'm not even sure that everyone is fluent with that. So, but I'm thinking maybe even snapshots should be treated as a new observability signal, a new telemetry to look at. And I know that many platforms out there, I don't know, Sentry and Bugsnap and many others that use. I know that Rookout obviously started consuming this sort of signal, the snapshots, and build out the image of errors or things like that based on that. So can you give us, take us to the 101 of what exactly snapshots are, maybe in a greater detail than what you said, and what can be done on top of them, maybe what the industry is, where the industry is taking it?
So as you mentioned, snapshots started a while ago, mostly as part of the exception tracking flow. Exception tracking tools came up with the concept that exceptions are bad. I mean, they didn't come up with it, but they kind of highlighted that if exceptions are bad, then we probably want to collect more information about them. And so the first obvious choice, especially in higher runtimes, especially in higher languages where it's easier to look at the state of the application, you can just get a snapshot. Let's say an exception was raised or thrown somewhere, depending on what language you're using. Let's take the stack trace of where it was thrown from. Let's get all the local variable values. And the more we can collect about the state of the application, essentially take a snapshot of the state of the application at that point in time, the easier it's going to be for an engineer to come later on and analyze this exception, rather than just reading in the log somewhere an exception was thrown. And the more accurate and the more fuller we can make this snapshot, the easier it's going to be for developer. And also, as you mentioned, the more friendly it's going to be, because it's going to look and feel much more like a live debug session rather than an traditional observability tool. Now, over the past few years, came by Rookout and a few other companies that said, if snapshots are so powerful, why not get it everywhere? I mean, I know exceptions are supposed to be bad, but there are two caveats here. First, not all exceptions are bad. Some exceptions are expected as a standard flow of the code. And on the other hand, many bad things can happen that are not an exception. And not to mention that by the time an exception is thrown, you might not actually have the data you need to investigate it. So it might be too late. And so tools such as Rookout kind of bring more agility to snapshots. So instead of having snapshots when an exception occurs, get a snapshot whenever you want. And this is kind of the observability equivalent of a traditional debugger, of a breakpoint. Tell us what line you want, and we'll get your snapshot from that. You can even dig in deeper by using a conditional breakpoint. So you tell us under what conditions you want to get a snapshot from this line, how many snapshots you want, and so on and so forth. And those kind of tools provide you with, let's say, if tracing were a more verbose form of logging, then snapshots are way, way, way more verbose form of logs.
Yeah, because they give the full stack trace, they give you the variable values and everything that is really really deep dive on a specific, like this is part of the root cause analysis, part of the stage of the incident treatment where the developer needs to now drill down into the bits and bytes and understand exactly where things fell and failed and why. I think this is interesting actually. Because I really see that put to use in many more systems and more vendors and more companies, and I think it will soon establish its own right as a pillar in its own right.
The one interesting thing about snapshots, besides open source, we can talk about that later, is that snapshots bring to light a whole new level of dynamicity or requirement for dynamicity, because logs, what we've discussed early on in this conversation, that you need to adapt observability. Adaptation can be, most of the time, you can add a log line in 30 minutes. It sucks, but it's reasonable. You can often live with that. Often you can't, especially if the system is right now down, you have a critical bug, and maybe your flows are not that quick, and you need 3 days or a couple of weeks to deploy a new log line. That all sucks. And yet somehow, we've managed to deal with the suckiness and take however long it takes to add a log line. But snapshots, because of their nature, because they're hyper-focused, and they require us to be very accurate about where we want them. And to make that an option, a viable option, we need to make that, because we don't know ahead of time where we're going to want it, we need to make it very, very dynamic. We need to be able to decide in real time where we want to get a snapshot from, which kind of brings to light the new concept of dynamic observability and real-time instrumentation, essentially allowing you to decide in real time what data you want. Now, this is also applicable for logs. I mean, all of us would prefer to have a log in 3 seconds instead of 3 weeks, but somehow we've managed. Snapshots, you just can't do that. I would argue, though, for all of pillars of observability, being more dynamic, being more agile is going to be a huge boon in creating better observability and also reducing the amount of work we have to do around that.
Yeah, I think also if we go back to what we talked at the beginning about the difference between the dev observability and the ops observability, one of the characteristics of the dev observability is that the developer needs different types of observability, different questions depending on where it is, where he or she is in the software development lifecycle. If it's now about to release a new feature into production, or maybe on the other end of that, end of life of deprecating an API, or end of life of a feature, or thing like that. Or of course, bug and incident investigations, and then you need to put the spotlight on different areas of the code. And obviously, you don't instrument for the worst case scenario that you would need to put the spotlight everywhere. It's not feasible. So I guess the need for the dynamic nature that you talked about is much more crucial when it comes to developer observability, because now the developer says, okay, I need to dig in here. Now I need to add, even if we look at the traditional signals, logs or metrics here, not to mention if you want, as you said, the snapshot. So I think that the dynamic part is becoming, it's useful also for ops, but here it's not a nice to have, it's a must have, I think, in a way.
Yeah, exactly, as you've said.
And let's talk about in terms of, because we all want these sorts of capabilities, but the question is, how much of that is, can you give us where the industry stands in terms of snapshot support and built-in support? We know what logs and metrics and traces support are, but this is again a relatively new, less familiar area. Which runtimes of different programming languages do they have that built in? What can be used out of the box? What needs additional tooling on top of that? Where does the industry stand in terms of that?
So the industry is, I would say, somewhere in the early days of VMware, where we all of a sudden saw that virtual machines are possible, but support within the silicon, within the CPU wasn't all that great, and a lot of emulation went into play. So, although from a technical perspective, we're probably way better off because we're actually seeing great performance and great stability. So it's truly production grade. If you look at so maybe it's more around having hardware virtualizations, but no standard hypervisors yet. Though I might be geeking out too much for the audience at this point, so I'm going to shut up. Anyway, today we're seeing that there are mainly 2 sets of tools that are used for instrumentation. The first is debugging APIs, debugging tools that weren't built for production usage. They can often be adapted to that. It requires great, significant effort, but even more so, a lot of careful testing, because let's say, for instance, I hate to say it, but the Node V8 engine has several memory leaks when you use the debug APIs. Now, those memory leaks are not that bad by themselves, and you are probably never going to encounter them in any debug session you're going to hold, because your RPS is going to be low, because you're probably not going to keep the server running for more than a couple of hours, and you'll never notice them. But if you're going to run that, if you're going to open that API at scale in the cloud, something that deals with hundreds of requests per minute, and then you're probably going to pop up those memory leaks, and all of a sudden you're going to have to walk around them very carefully. You're going to have to test that. And that's one example. The other element, which kind of helps make real-time instrumentation an option, is about instrumentation in general. It's kind of how traditional observability has been done. And some runtimes, I would probably point out Java as being the most, JVM as being the best. It has pretty solid support. It actually goes back to Java 1.5 or 1.4, depending on which API you're using, which is kind of beginning of the century. So it's very widespread. And there are also a lot of open source tools, probably 5 or 6 different open source tools and frameworks. My favorite is ASM, that are built around that technology. If you're looking to dive in deeper about JVM, by the way, my colleague Yarden gave a talk at Dev Days Lithuania, so you can Google that and take a look at it. And so when you look at that we're seeing more and more tools out there that offer some level of support, but it's the thing is, it's not standardized. So if you're looking to do real-time instrumentation for the JVM, you're going to use the Java Agent API, while for Python, you might not have a tool at all. You might resort to native extensions. For Ruby, there is actually a pretty decent API that you can use out of the box, except it was added in Ruby 2.6, which is I think about 3 years ago. It was properly documented in Ruby 2.7, and they had a couple of bugs there I reported, and they got fixed, I think, for 3.1. And so it's very, very messy in that nature. And I think as an industry, kind of like we're working on open telemetry and open metric, trying to standardize, or like, we've built the OCI, the open container image specification. The more we understand that snapshots in general and real-time instrumentation are important, we should do a better job at trying to standardize it, trying to determine what kind of APIs should the runtimes provide for that, what kind of format should you use, so that it's going to be easier to interoperate them. And the better support the runtimes are going to offer, the better the end result is going to be.
Actually, it's interesting while you were talking and mentioning the example that for static languages it makes sense, but actually what you're saying is that also for dynamic languages that you would argue that okay, but you can modify that at runtime. You still see the very same need to create the built-in instrumentation within the runtime to enable that, right?
Yeah. Today we support the JVM, the .NET, Python, Node, Ruby, and Golang. Actually, Golang was by far the most challenging because we are working directly at the CPU instruction level without any isolation or abstraction, directly with the x86, x84, ARM opcodes, without any middleman. But regardless, yeah, I mean, as long as you're running code, and I would argue in the future for no code or low code as well, as long as something is being executed, being able to instrument it and re-instrument it without having to stop the application, without having to change the state, and let alone get snapshots from it, those are all super useful tools that we should strive to make the standard for every developer out there.
So I think this leads to a question that we have from the audience. The question is, snapshots and code level visibility are not part of the open source technologies. Why not? And are you going to have you any goals in trying to get it into the open source or open standards or similar?
So, as I mentioned first, it's very important for me personally to help standardize things, to help make it easier to build and use those tools. I think for us at Rookout, it's always been a challenge about how we not just open source it, because we can definitely open source significant portions of our technology, but they're not going to be usable as open source. So it's not just about open sourcing the technology, it's making the technology a legitimate open source product or a legitimate open source project people can use and benefit from, because otherwise we're just saying something is open source but without making it a viable product. And I've seen some companies do that. I have to say I'm not a huge fan of that approach. And so it's definitely something we have in our sights. How can we make it a viable open source project? How can we make it usable for as many engineers out there? I would mention that we do offer a free tier on our SaaS platform, so that we do want to make it accessible even today in the SaaS, so people can start using it as much as possible without paying us tons of money or without paying us at all.
Sounds good. I have another question that goes back. Maybe this is not specifically about dev observability. It's common problem both on dev on the ops side, and especially on heavy telemetry such as Snapshot, which is the cost. Because on the one hand, we say we need to collect as much as possible and get as much visibility as possible. And also on the iterative process we talked about before, you learn on the fly with time that you need more things, and you have gaps here and there, and you start filling in these gaps. But that comes with the cost. Oftentimes it's the problem of the specialized ops team that we talked about, and the devs are less immediately exposed to that. But ultimately it rolls down to the devs, because at some point they're shut down saying, okay, you can't do this, or you can't. Especially in the pre-prod, suddenly you say, okay, but you can't have the same, even if you realize the benefit, but suddenly you're blocked from implementing similar on the staging or pre-prod or dev environments because the costs are prohibitive. So how do you see the cost part and how to manage that aspect?
So when you're thinking of cost, I'm guessing you're thinking of kind of performance cost of the snapshots and how they impact the application as a whole.
It's both the performance cost in the application. It's also associated cost in storage and associated. But let's start with the performance, which is again very significant. And then we'll talk about the other costs.
So obviously, when it comes to snapshots, you can get big snapshots, you can get small snapshots, and the bigger the snapshot is going to be, the longer it's going to take that snapshot. Now, as I recently, I think just last week, I gave a talk in PyCon about how we made our snapshots faster, and essentially I started a conversation with, of course, our customers want both. They want the biggest snapshots possible. They want to make it the most quick as possible. So, and obviously there are trade-offs, and you can take very small snapshots just showing you the local variables, and they can make it be very fast, or you can get very, very large snapshots, which are going to be a bit slower. Just to give you a reference point, the numbers we're looking at are somewhere between 0.5 millisecond and 5 millisecond per snapshot. It varies greatly, mostly due to the runtime. And as you would expect, faster runtimes such as the JVM or Golang tend to have way faster snapshots, while slower runtime, and I hope nobody's going to take offense, but such as Python, take a bit longer on how long it takes to get a snapshot. Now, the thing is, it's not just about the snapshot itself, because the individual snapshots, if you check just one snapshot, especially if you have a high load system, obviously it's going to make one request slower. You can even take 10 snapshots, but you won't see it not even on your P99, because one snapshot is not going to make any impact on the system as a whole. And so a more interesting question, I would say, is kind of what's the collective impact? And to do that, we actually have tons of safeties in place. Whether it's about restricting a snapshot that once it's been invoked, you can control how many times it's going to be invoked. If you accidentally put a snapshot in the middle of a loop or some place that's very hot, we're going to automatically detect that and move it into sampling mode. You can use conditional breakpoints, conditional snapshots to only get the snapshots when you actually need them and not anywhere, not every time this line of code is being passed. And all of those safety mechanisms ensure that you won't be impacting the environment as a whole in any meaningful way, even though you can very surgically, very agilely just get the data you need to get things done.
Sounds good. And moving to the associated storage costs of the aggregated information, as the more metrics we collect, and much more verbose, obviously, the traces and the snapshots. How do you see any optimizations and guidelines that you found useful there?
So ironically, because snapshots are, I would say, argue unjustly perceived as expensive, you just don't collect them that much. And also, you don't need to collect that many snapshots because you have the full control. Think about the logs. I mean, you guys are aggregating logs and you store tons of logs for your customers. And they probably don't use significant portion of that logs regularly. I know that when we ingest logs, we never look at most of the logs we ingest, but we need them because if we're not gonna write them down and ingest them, then they're not gonna be there at our time of need. And so everybody I know takes the approach of better safe than sorry because that's the only practical way. Because as we discussed earlier on, adding a missing logline is going to take you anywhere from 30 minutes to 3 weeks. So you need those logs. You can't equivocate on that. Whatever logs you think you might need, you're going to send them, and then you're going to end up with 3, 4, 5 times orders of magnitude more logs than what you actually use. Snapshots are much closer to 1-to-1 ratio. When you need a snapshot, you instantly get it. You don't have to worry about, you don't have this FOMO of, I need everything. And so you just don't collect that much. You collect crazily little. Looking at most of our customers, I think they use, I would say, somewhere between 30 and 40% of the snapshots they're getting. Compare that to what you see with logs, it's worlds apart. And so because you're using 30-40% of what you're getting, how much can you use? Triple that's how much you're getting. That's how much you're storing. It's really nothing.
Sounds good. So we're about to end this part of the program. Before going to the breaking news, I'd like to maybe have an opportunity to hear about your podcast, and if you want to tell the audience, and hopefully fan podcasters, they will want to check out.
Awesome. So I have a podcast called The Production First Mindset. We've started that 9 months ago now, and it's been going strong. We've actually published an episode every single day, speaking with engineering leaders, some occasional relevant vendors, and other thought leaders. The reason I've started this podcast is because I found that engineers were segregated away from production. I mean, everybody's talking about developer ownership and developer empowerment and shifting left, but still developers don't feel at home, and in many cases are not welcome in production environments. They're seen as those, careless kids that are gonna click on the power off button once somebody gets them access and everything's gonna go down, or they're gonna be running around dragging cables along the data center. And I definitely don't advocate giving everybody access to production in the traditional sense of letting them SSH into machines. In fact, if you can, don't let anyone SSH into machines. But we do want developers to feel at home in production. We do want to make them feel welcome. And if we do that, we need to put in not just the tools such as Rookout that make it possible, but we also need the culture for that. We need the processes for that. And that's what this podcast is about. It's about seeing how different companies, how different engineering organizations deal with the challenges of working in production, first and foremost, and managing their production environments, but even more so about how to make their engineers welcome in production so that when they get a bug, when they get a customer request, when they get a customer support ticket, whatever whenever something is happening in the real world, in the business the company cares about, that engineer is going to be connected to it and empowered to own it and fix it, rather than just something happening in a very far away land they've never heard about, they can't access even if they want, and let the ops people or support people or whoever it is on the other side of the fence deal with it.
Sound good. So production first mindset. And where can people catch up with you after this podcast? I know that you're very active on Twitter and more so on LinkedIn. What would be the best way to reach out to you?
So LinkedIn Liran Haimovitch would be great. I also have a Twitter handle, which I honestly don't remember by heart. So I'm going to look it up because
I think it's Liran_last. LIRAN_last. So
that's me. As I mentioned, I kind of don't give that handle that often, so I can tend to forget it. And you can also always email me at liran@rookout.com or anywhere else you feel like.
Great. So, Liran, I want to thank you very much for this conversation, and I would like to invite you to join me to the next part, which is the breaking news. And
Awesome.
for the breaking news today, I'd like to first mention something that I was quite excited to hear about Istio. Istio is a very popular service mesh technology, and Google is now going to contribute Istio to the CNCF, the Cloud Native Computing Foundation. So Istio applied to become a CNCF project. I know it's been long awaited for, and it was under discussions between Google and other members of that community, like IBM and others. So, and being, like, I think, vastly the most popular service mesh solution out there, it makes perfect sense to be there under the same umbrella. Any thoughts about that?
I can't say. I know service mesh technologies are always changing, and there are a few paradigms. You have the north-south versus the east-west technologies. Some of them work better this way, some of them work that way. You have the eBPF movement, which is all about moving as much as possible to the Linux kernel for performance reasons. And it's kind of one of those places where I would want just I'm still waiting for someone to just tell me what's the right approach, rather than having to learn every single option and make every decision. I think that's one of the things that can be very challenging at open source sometimes. There is no one right way, even though that for most of the use cases, you probably don't want to learn about the differences yourself.
Yeah, that's true. And young technology, this is a classic evolution of young technologies that they bring new concepts, and you need to let it stabilize and converge to get things a bit more streamlined. Another thing that I wanted to share with the audience, it's an interesting article or blog post that I read that was published a few weeks ago with some experience shared. We talked about, actually, in our conversation, about the fact that sometimes you need specialized teams, dedicated teams within the organization to own observability. And that was actually a post by someone from Shopify, like a web scale type of organization. He covers why they need why they need a dedicated team for observability, and the roles within those specialized teams. And again, a dedicated observability team, not just a generic SRE or DevOps. So I think it was a very interesting blog post. I'm posting it. Also, the news bit about Istio joining or applying to join the CNCF. So everyone's welcome to join. By the way, it corresponds nicely, as I mentioned, with the episode that we've had here at Open Observability Talks with Suman Karumuri from Slack, about his experience in Slack, in Twitter, and Pinterest, and other companies about observability in web scale organizations. So that's another thing that I wanted to share. And maybe the last bit for today, as time permits. On the last episode, we talked about OpenSearch. So now following up with great news, releasing the Kubernetes operator for OpenSearch. finally here. It's been a popular request with the community since the very first period in OpenSearch project a year and a bit ago. So finally seeing that released and developed by Opster, another startup from the Israeli ecosystem. Very nice to see them, but together with Rancher, Susi, of course, and others. I'm glad that we at Logs.io were able to also contribute to this effort. So it's now released under Apache 2.0. And like an any operator used for automating the deployment, the provisioning, the management, the orchestration across multiple clusters, both for OpenSearch and for the OpenSearch dashboard. So the front end piece, sort of the equivalents of Elasticsearch and Kibana, that's OpenSearch and OpenSearch dashboards, the two components. So anything, scaling up and down, version upgrades, rolling restarts, adjustments of memory and disk resources on the nodes and things like that, you can now automate through and streamline through this. So that's another interesting piece that I wanted to share with the team. I'll post here also for the ones on the live stream. The links, obviously, all the links will also be available on the show notes on the podcast. So if you're listening on the podcast, you'll find them on the show notes. And by the way, in the future releases, there are also plans to for advanced shard allocation strategies, monitoring with Prometheus and Grafana, control of shard balancing and allocation, auto scaling based on usage load and resources, and many other very, very useful things that will come out of that. So stay tuned if you're a Kubernetes native. Very worthwhile checking that. And we're about to come to the ending of this episode. So I wanted to thank you again, Liran, for joining me for this episode.
It's a pleasure. Thank you for having me. It was a pleasure.
Thank you very much, and thank you everyone who joined us for today's episode. As always, all the episodes can be found on the favorite podcast apps, or on YouTube. So check them out. And if you are listening to this episode on the podcast apps, do know that we stream the episodes live on Twitch and YouTube. So you're more than welcome to follow us on Twitter or other places to find out the live stream times and join us to ask your questions and make your comments. You can find all the details at openobservability.io, or you can follow us on Twitter at openobserve for updates, to share your comments, suggestions, news bits, or just reach out to me directly at Horovitz on Twitter, HOROVITS. And of course, if you are a subject matter expert and you want to, you have something to contribute from the community, do go ahead and submit a talk proposal on openobservability.io or reach out to me directly. We'd be more than happy to have more people from the community contributing. And with that, thank you very much for listening to us. And until next month's episode, I'm Dotan Horvitz, and thank you very much.